sklearnmultioutput. Description: explain in detail. Multi-output regression is a type of supervised learning where a model learns to predict multiple target variables simultaneously. It's used when you have multiple correlated outputs that need to be predicted based on a set of input features. Inputs. Input 1. Explain in detail. The input data is usually a 2D array or a pandas data frame containing features that will be used to predict the target variables. Each row represents a sample, and each column represents a feature. Input 2. Explain in detail. The target variables are also provided as a 2D array or a pandas data frame, where each row corresponds to a sample and each column corresponds to a different target variable. Outputs. Output 1. Explain in detail. The model predicts multiple target variables, and the output will be a 2D array or data frame containing the predicted values. Each row represents a sample, and each column corresponds to a different predicted target variable. Output 2. Explain in detail. In addition to the predictions, you can obtain information about the model's performance, such as the R-squared score for each target variable or the mean absolute error for the entire multi-output prediction. Steps. Step 1. Explain in detail. First, you need to select a multi-output regression algorithm, such as random forest, gradient boosting, or multi-output linear regression. Step 2. Explain in detail. Next, you need to train the model on your input data and target variables. Metrics. Metric 1. Explain in detail. R-squared R2 score for each target variable. This metric measures how well the model explains the variance of each individual target variable. A higher R-squared value indicates a better fit. Metric 2. Explain in detail. Mean absolute error. This metric calculates the average absolute difference between the predicted and actual values for each target variable. A lower may indicates better accuracy. Visualization plots. Visualization plot 1. Explain in detail. Scatter plots for each target variable. You can visualize the relationship between the predicted and actual values for each target variable using scatter plots. This helps to understand the model's performance and identify potential areas for improvement. Visualization plot 2. Explain in detail. Residual plots. You can also plot the residuals differences between predicted and actual values for each target variable to check for patterns or trends that might indicate problems with the model. Fine-tune parameters. Parameter 1. Explain in detail. Number of estimators for tree-based models. This parameter controls the number of trees in the ensemble. Increasing the number of estimators can improve the model's accuracy but also increases training time. Parameter 2. Explain in detail. Learning rate for gradient boosting models. This parameter controls the step size taken during the optimization process. A smaller learning rate may lead to better accuracy but requires more iterations. Uncertainty methods. Uncertainty method 1. Explain in detail. Confidence intervals. You can calculate confidence intervals for each predicted target variable to estimate the uncertainty in the predictions. Uncertainty method 2. Explain in detail. Predictive variance. Some models provide a measure of a variance of the predictions, which can be used to assess the uncertainty. Challenges and fixes. Challenge 1. Explain in detail. Data imbalance. If the target variables have significantly different distributions, the model may favor the target variable with more data points. Sample use case that resulted in challenge 1. A dataset where one target variable has a very wide range of values and the other has a narrow range. Fixes to challenge 1. Normalize the target variables. Rescale the target variables to have similar ranges, which can help the model learn equally well for all variables. Challenge 2. Explain in detail high correlation between target variables when target variables are highly correlated. The model may struggle to learn separate relationships for each variable. Sample use case that resulted in challenge 2. A dataset where two target variables are almost identical. Fixes to challenge 2. Feature engineering. Try creating new features that capture the combined information of highly correlated target variables. Dimensionality reduction. Consider using techniques like PCA to reduce the number of target variables.